Welcome to this presentation. It's on question 14 of Step Paper 1 2001. Let me read the question. On the basis of an interview, the N candidates, that's big N candidates for admission to college, are ranked in order of their mathematical potential. They're interviewed in random order. Find the probability, this is part 1, that the best among the first N candidates interviewed is the best overall. Okay, well, what that's saying, we'll just do the first part, I'll read the other parts later, is that where is the best candidate? Is it in the first? Okay, let's try. Here we've got big N candidates, and here they are, we're interviewing in this order, and here is the first N of them. Question is, where is the best? If the best is in the first N, then that's the probability we're trying to find. If the best is beyond the first N, then that's the opposite of the probability we're trying to find. So for part 1, the probability that the best is in the first N, this is pretty straightforwardly small n over big N. And the only tricky thing is to realize that in this wording, that the probability the best among the first N candidates is the best overall is equivalent to saying that the best overall is within the first N. Once you realize that, it's quite easy. So let's look at part 2. Part 2 is asking us, what's the probability that the best in the first N here is either the first or the second best overall? And it's easiest to do these sometimes when you've got an OR by thinking about the opposite of this, and then in the end we're going to subtract over 1. So the opposite of this is that the best in the first N isn't the best overall, and it's not the second best overall. And that can only be true if, and I'll just change colour here, if the best and the second best are in the second part of the interview sequence. In other words, they're in this line here, which is n minus n. So the probability that the best is in the second group is equal to n minus n over big N, just the probability that it's there. The probability that the second best is in the second group, in the rest of the second group, perhaps we should say, because we've got the first best ones here, so we're looking for the probability that the second best is in what remains here, and what remains are n minus 1. It's n minus 1 overall because the best is already spoken for, minus n over n minus 1. And probability that they're both in the second part, the second group, is that one of those things times the other, n minus n upon n minus 1 minus n over n on n minus 1, and the answer we're looking for, the probability that at least one of them is in the first group, is 1 minus that thing. So the probability we're actually looking for, the probability that the best or the second best is in the first N, is equal to 1 minus all of that. I'm writing it out again. So let me now try and work this out a little bit, and let's make a common denominator. And 1 minus all of this is n squared minus n. That's the 1 over this, minus all of what we have here. I'm going to put a big square brackets here, and now I'm going to multiply out this expression here, and I will get big N squared multiplied by n here, minus n minus n, small n, big N. I'm going to multiply by the small n, so it's minus another n plus n squared. Now let's take a different color to do some cancelling. Red is the color for cancelling. You can see that that n squared and that n squared cancel, and that n there cancels with that one. And so what we're going to end up with here, formula to finish, is equal to, oh well, minus nn is minus 2nn, 2nn, it's plus now because that minus turns those into plus, minus n squared minus n all over big N on n minus 1. And that's the formula that we're trying to find. So let's just now do the last part. And the last part says, verify your answers for the case n equals 4 and little n equals 2 by listing the possibilities. Well, let's work out what our answer tells us here. When big N equals 4 and little n equals 2, this probability is equal to 2nn, 2 little n big N, is 2 times 8, minus n squared, which is minus 4, minus n is minus another 2, divided by big N upon n minus 1, which is 4 times 3. And that equals 2. 2 times 8 is 16, minus 4 minus 2 is 10 over 12, which is equal to 5 over 6. So this is saying that if you interview the 4 people, 4 candidates, you have 5/6 of a chance of getting either the best or the second best in the first 2. And then it asks you, finally, to work out by counting all the possibilities. I'm not sure if they really mean you to list all the possibilities. Perhaps they do. But if you've got 4, A, B, C, and D, where the ability is determined by the position in the alphabet, A being the best, then there are 4 factorial, 24 possible ways of writing this down, of not writing it down, or of sequence of interviews. So let's try and do this reasonably economically. We could have A, B first, and then C and then D, or then D and then C. Or we could have B, A first, and then C, D, and D, C. Or we could have A and then C, and that could be followed by B, D, or D, B. Or we could have C, A first, followed by what's left, a BD or a DB. So what else could we have first? Every combination with first, there's two possibilities for fitting in the other 2. So we could have AD first, we could have DA, we could have BC first, or CB. We could have BD first and DB, and finally we could have CD first or DC, and each of those have 2 possibilities for the way the last 2 are fitted in. And let's just look and see what we've ended up with here. We've ended up with 1, 2, 3, 4, 5, 6 groups along the top and 6 along the bottom, each of which have got 2 possibilities. So that makes a total of 24 possibilities of sequencing, which is indeed the 4 factorial that we knew we ought to have. And so what we need to do is look here to see which of these have got C and D first. And of those, it's only these which have C and D, which is 4 possibilities. And all the others have either A or B, or in this case both, in the first position. There's A in the first position, and there's B in the first position. So out of the 24 possibilities, all but 4 have got A or B in the first position. So that means, I need a little bit more space up here. This is different doing it on a blackboard than doing it in paper, where you can just take more paper. If I squeeze in here, that means that 20 out of the 24 possibilities have got A or B in the first 2 positions, in one of the first 2 positions. And that, of course, is equal to 5/6, which is what we expected it to be when we worked it out like that. So we can give ourselves a tick. We've done the problem, and that's the end of the presentation.